Good morning. So my name is Sarah. Monitoring number is 264 and 400. Our group will discuss about the general assignment problem for boutique service from previous assignment 2, and we take the data from the assignment 2 to assignment 4. So our problem statement is from the previous assignment. We are referring the data about the teller have one design of wedding dress that have to be sewed. So we are going to use the initial solution that we got from the previous assignment and use it here to do for 3 different meta heuristic, which is Tabu search, simulated annealing, and genetic algorithm.
My name is Farah Diana binti Norais, and I'm going to present about the description of word solution. General assignment problems have proven to be not fully complete and cannot be solved in polynomial time. Solving such problems of reasonable size often relies on heuristic approaches. Recently, several meta-heuristic approaches have emerged as efficient tools for solving such problems. However, the development and implementation of such meta-heuristic have not been a trivial issue. The merits of each method and the problems involved in implementation may not be easily apprehended by practitioners, thereby posing difficulties in the selection of an efficient heuristic for business applications. For this reason, a comparative study of 3 important meta-heuristic approaches, which are simulated annealing, genetic algorithm, and Tabu search, for both binary and comprehensive general assignment problems, was carried out in our group assignment 2, and the worst solution that we got is that is equals to 817. To test the performance of the 3 meta-heuristics, 2 binary performance indices and 2 generalized performance indices were respectively used for binary and comprehensive assignment grouping problems. The comparisons were made in terms of solution quality, search convergence behavior, and pre-search effort. The result indicate that simulated annealing outperformed both genetic algorithm and Tabu search, particularly for large problems. The genetic algorithm seems slightly better than the Tabu search method for the comprehensive grouping. For the simulated annealing approach, the best found solution is that is equals to 856 and that is equals to 860. Based on the calculation that we did, we can see that when the temperature increases, the probability to accept worst solution is increased too. And when the temperature drops, the probability to accept worst solution will drop too. Problems.
My name is Tabu binti Muhammad Ramli. With the metric number is 265534. I will explain about the result and discussion. The one way we need to improve the solution using meta-heuristic is the Tabu search. The first thing we need to have before we start to solve the problem is we need to have the initial solution. Our initial solution is 817. We have a 3 iteration and then we have a 15 swap. For the iteration number 1, we define that the minimum total cost is the 833, which is we swap B and P. After we swap B and P, in the iteration number 2, we define that the minimum total cost is the 826. B and P were released in the Tabu list, which is we swap F and P. The B and P were released in the Tabu list number 1, and then D and P were released in the Tabu list number 2. So I can conclude that from 3 this iteration, the best solution so far is the 826, which is we swap D and P at the iteration number 2. Thank you.
So for the next one is genetic algorithm, and we have 2 initial solutions. Each initial solution represents each parent. So we have that is represent A, B, C, D, E, F, G, H, I, J, K, L, M, N, and P. We didn't include O because it will be confusion to between O and 0. So the question is maximize the total of identified design produced, obtain new solution population through a 2-point crossover with the crossover and mutation probability being 0.6 and 0.4 respectively. Use the following set of random number 10 and 5 because we only have two initial solution. For the parent selection, the total is 817 and 821 for parents too. The percentage for each parents is 50%, that would make it 100%, and then the cumulative percent that we got for parents 1 is 50 and parents 2 is 100. The range for parents 1 is 0 to 49 and parents 2 is 50 to 99. Next is the crossover. The crossover probability is 0.6 times with 2. 2 is our initial solution, and then we got one chromosome. Okay, so we divide it. We are using 2-point crossover. So this is our parents and this is our children, the parents 1 and parents 2. So the parents 1, we just change to children 2, and the parents 2 we change it into children 1. We have to change the middle one. So parents 1 change with children 2 for the middle one, and parents 2 change with the middle one for children 1. And the next one is mutation. Mutation probability equals to 0.4 times 2. We got one cell. So from the crossover, we got the children. So the children is we swap two cells between two cells, even though we need one cell only. So we swap 12 and 15 and 12 and 7 for children 1 and children 2. And the next population will be, so the difference is here lah, 15, 7 and 12, 12. And our elitism is 6, 10, 11, 15, 1, 7, 12, 4, 9, 3, 8, 5, 2, 13, 14 from parents 1.
In the conclusion part, we can conclude that to improve the solution, we need to use a meta-heuristic, which is we have a Tabu search and genetic algorithm simulated annealing. In the Tabu search, we need to improve the solution using a local search, which is a neighborhood. And the simulated annealing, the problem is solved by formulating an objective function. We need to set the temperature and random number to be selected to know whether the solution is rejected or not rejected. For the genetic algorithm, we need to solve the problem by relying on biologically inspired operators such as mutation, crossover, and the selection. Thank you.